Okay, hello everyone. From this video we are going to start to discuss about unit 2 of your core 8 paper, that is your mathematical physics. In this video we are going to discuss about Fourier integral theorem. That is, here is the statement. This theorem states that any non-sinusoidal function fx having period 2l, that means exist in between minus l to l, can be represented as like this: fx equal to 1 by pi 0 to infinity into minus infinity to infinity f of t into cos omega t minus x dt into d omega. Before we have to prove this theorem, first we have to discuss about basic idea about spatial domain, time domain and frequency domain, which is required to explain this theorem, right? Here you can see that this is a sinusoidal wave, and this wave is represented in spatial domain. That means this, along this axis we have been considered as variation of x. Each and every point of x, what is the value of this function has been represented. That means this is the spatial domain. Okay. Or this signal, that may be audio or video signal, represented in spatial domain, you can say. Then time domain means variation along x-axis, variation is your time, and representation along y-axis corresponding f of t, the sinusoidal wave. Okay, so this is your time domain. Now if we are going to consider corresponding frequency domain, then the frequency domain will be like this. Along this axis, along x-axis, we have been considered the frequency, variation of frequency 1 2 3 4 belongs to frequency, and along this y-axis your amplitude. So here you can see, along in time domain, suppose in 1 second 2 waves has been crossed this point. Suppose 2 waves has been crossed at this point, where from this to this is your 1 second. So in 1 second 2 waves has been crossed, means the so-called frequency will be 2. So hence in the frequency domain it will be exactly at 2 one peak will be observed. So here time domain transformed to frequency domain, we can get only one peak. That means only one frequency exists in this sinusoidal wave, right? Now another example we are going to take with higher frequency. This is representation in spatial domain, this is representation in time domain, but exactly at this distance is your 1 second, this distance also 1 second. In this 1 second, suppose we consider one this length is one wavelength, 1 2 3 4 5. So 5 wavelengths has been crossed at 1 second. So if I am going to transform this time to frequency domain transform, then we can get only one line exactly at 5. That means this signal has only one frequency, have value is 5, right? Suppose we have a audio or video signal having various frequencies. Suppose you consider a light having RGB, red, green, blue wavelengths are mixed together. So when this light will be dispersed, then red light, green light and blue light we can found. So that means 3 frequencies mixture or more than one frequency mixture, one signal suppose we found like this. This is a non-sinusoidal signal somewhere we found, and if I transform, this is in the time domain, if I will transform from this time domain to frequency domain, then we can found like this scenario. Means here at 3 1 peak, at 6 1 peak. That means in this signal only 2 frequencies are exist. Okay, so by transforming from time domain to frequency domain, we can easily identify how many frequencies are exist. So any one of the frequency easily can be filtered out. Okay, so this is this process is required to signal processing, that you are going to study in your higher studies. So here we have been concluded that both spatial, time and frequency domain are connected with each other or coupled with each other, okay, which will be required to explain this theorem, right? So now we have to start our proof. So here we know that first here starts that we know that Fourier series of a function, suppose fx, which is exist in between minus L to L, is this one, fx equal to a0 by 2 summation over n equal to infinite, n equal to 1 to infinity a n cos n pi x by L, summation over n equal to 1 to infinity b n sin n pi x by L. Let this is your equation number 1. So here I suggest one thing, that you start the unit 2 and you write this one first. First you write this one, then you write starts from this theorem. Okay. And here a0, the Fourier coefficients, a0 is your 1 by L minus L to L f of t dt. So here why we considered f of t dt, as we saw that the spatial domain can be communicated to time and time domain can be communicated to frequency. So here this spatial function can be written in the form of time domain. So a0 will be written as 1 by L minus L to L f of t dt, an 1 by L minus L to L. Actually it has to be written as f of x, but as we discussed that spatial to time domain can be possible, so f of t cos n pi t by L into dt, bn will be 1 by L minus L to L f of t into sin n pi t by L into dt. Now put a0, an, bn in equation number 1, we get f of x, that implies f of x will be equal to here 2 is already there, so this will be 1 by 2L minus L to L f of t dt. Just I have been substituted, instead of an here, bn here, so 1 by L minus L to L, summation is there, f of t cos n pi t by L into cos n pi x by L into dt, and here 1 to infinity summation 1 by L minus L to L f of t sin n pi t by L into sin n pi x by L into dt. That implies f of x 1 by 2L, this term is there, nothing has been changed, and here summation has been taken common and 1 by L also taken common from these two terms we found, and also integration of minus L to L f of t taken common from these two terms we found, cos n pi t by L cos n pi x by L is there, plus sin n pi t by L into sin n pi x by L into dt. So this is in the form of cos A into cos B plus sin A into sin B, that means cos A minus B. So fx will be equal to 1 by 2L minus L to L f of t dt plus summation over 1 by L minus L to L is there, f of t into this one. This one will be written as cos A minus B format. Cos A is your cos n pi t by L, cos n pi t by L minus cos n pi x by L into dt. Okay. Now here we can take n pi by L common from these two terms. Okay, so what it will be? It will be fx will be equal to 1 by 2L L minus L to L f of t dt, summation over n equal to 1 to infinity 1 by L to L f of t into cos n pi by L taken outside t minus x into dt. Now that implies f of x will be 1 by 2L minus L to L f of t. See, minus L to L minus L to L, both two terms into both the two terms are common, can be taken outside from these two terms. This will be 1 plus, here I have been written 2 into 1 to infinity, because whenever I am going to take common from these two terms 1 by 2L this much, then 2 will be obviously multiplied over here. So 2 into summation over n equal to 1 to infinity cos n pi by L t minus x into dt. Let this is your equation number 1. Right. Now this is the important step, that 1 plus 2, this one 1 plus 2 1 to infinity cos n pi by L into t minus x will be written as n equal to minus infinity plus infinity summation over cos n pi by L into t minus x. How it is? Already we know that cos x is your even function, that means cos minus theta equal to cos theta. So concentrate over here, this one concentrate on this, that means summation over n equal to minus infinity to infinity cos n pi by L into t minus x. So if I will expand this one, then it will be, suppose we are going to consider minus 4 to 4. Okay, minus 4 to 4 this much. If minus 4 to 4, then what we can write? We can write cos this one minus 4 pi by L t minus x, then plus cos minus 3 pi by L into t minus x, then plus cos minus 2 pi by L into t minus x, then plus cos minus pi by L into t minus x. Then another term will be here. I'm substituting the value of n first 4, then 3 summation 3, then 2, then 1, then n will be 0, then cos 0, then plus cos positive terms, that means 0 to again we have to move to 4, that means pi by L t minus x plus cos 2 pi by L into t minus x plus cos 3 pi by L into t minus x plus cos 4 pi by L into t minus x. So this value here you can see, as we know cos minus theta equal to cos theta, this value equal to this value. So if I will consider these two terms, I can write 2 into cos pi by L 4 pi by L into t minus x. Likewise these two terms will be add up, this 3 minus 3 plus 3 will be add up, minus 2 plus 2 will be add up, minus 1 plus 1 will be add up, and cos 0 is nothing but 1. So here we considered minus 4 to 4, then the answer is what? 1 plus 2 into, here I can write 2 into 0 to 4 cos n pi by L into t minus x, same. So if I will consider this one 0 to 4, 2 into 0 to 4, this can be written as minus 4 to 4 this much, because if I will expand, then I can found 1 for cos 0, and minus term and plus term will be add up, and it will be come to multiplied with 2. Likewise if we are going to consider n terms, that means n equal to g here, sorry, n equal to here here n equal to 1 to 4, because this value will be cos 0 equal to 1. So if we are going to consider n equal to 1 to infinity, 1 plus 2 this much can be written as minus infinity to plus infinity cos n pi by L into t minus x, as cosine function is a even function. Okay, hence equation number 2 will be fx equal to 1 by 2L minus L to L f of t, this much will be substituted and this much dt. Okay, fx equal to 1 by 2 pi minus L to L f of t. Here you can see that, see here we considered 1 by 2 pi, that means L I taken inside, pi I multiplied, means at the denominator pi multiplied means numerator I have to multiply 1 pi, so pi by L. Carefully watch, 1 by 2L is there, here I written 1 by 2 pi. L I have been multiplied pi, means I have to multiply pi over here, and this L taken inside this bracket, pi by L. F of t is there, and summation term nothing changed, dt, equation number 3. Let us consider L increases infinitely, that means very small, L increasing very small unit with very small unit, then we can write this one, this factor pi by L minus infinity plus infinity cos n pi by L into t minus x. Here I done one simple mistake, that here L is there, that means pi by L should be inside this summation. Okay, just correct. Okay, so here I put the whitener, so pi by L should be inside this summation, because n changes from minus infinity to plus infinity, and L increases, along with L increases infinitely. So that means the summation, inside the summation L should be there, L. So this is your pi by L, and here I written pi by L. So if L tends to infinite, summation over n equal to minus infinity plus infinity pi by L into cos n pi by L into t minus x equal to can be written as minus infinity plus infinity d omega cos omega t minus x. Let this is your equation number 4. How d omega omega came? Here you can see. Let we consider that pi by L is your omega n. N pi by L equal to omega n. So as we know that 2 pi by t is your omega. So t is the time period. Okay, so here is the period is your how much? 2L. Period is your 2L. So if I am going to consider omega n, then or omega will be 2 pi by 2L or pi by L. So for nth omega, nth frequency, it will be n pi by L, like this. Okay, so n pi by L is the dimension of frequency. So if pi by L is the dimension of the frequency, n pi by L is the nth frequency. So it is represented as omega n. So pi into n plus 1 by L will be written as omega n plus 1. So d omega, or change of omega or change of frequency, will be omega n plus 1 minus omega n will be pi by L. So d omega, instead of pi by L we can write d omega, and instead of n pi by L we can write omega, right? Okay, let this is your equation number 4. Now put 4 in equation number 3. So equation number 4, this one value we have to put in equation number 3. So fx will be equal to 1 by 2 pi all there minus infinity, because we considered L changes from infinite, increases infinitely to infinite. Okay, so minus L to L will be changes to minus infinite to infinite, minus infinity plus infinity f of t, and here here we can put this value over here. This value over here means cos omega t minus infinity plus infinity cos omega t minus x into d omega, cos omega t minus x into d omega minus infinity plus infinity, or as cos omega is your even function, we can write it 2 into 0 to infinity cos omega t minus x into d omega into dt. Okay, so here again I am going to explain one thing, that L increases infinitely or with very small up to infinite, up to infinite value. So only for that this summation is going to be transformed to integration, right? Okay, so here so this is our proof. Already we have been proved. So fx equal to this one. So here 2 got cancel. Fx equal to 1 by pi 0 to infinity and minus infinity f of t cos omega t minus x d omega dt. Hence proved what we intend to prove. This theorem, right? This one also can be written in this style, that fx equal to 1 by pi is there 0 to infinity cos omega t minus x d omega minus infinity plus infinity f of t into dt. Or we can write f of x will be equal to 1 by 2 pi cos omega t minus x d omega minus infinity plus infinity f of t dt. Here you can see why we written 2 pi. If I will multiply 2 and divide 2, the 2 into 0 to infinity is nothing but minus infinity plus infinity. Okay, so here you can see I multiplied 2 in the denominator and multiplied numerator 2. So instead of writing 2 into 0 to infinity, I can write minus infinity plus infinity. So these 3 style of representation are required at various places whenever we are going to prove the numericals. Okay, so here we have to stop our today's discussion. In our next class we are going to discuss Fourier sine and cosine integrals, and then Fourier complex integral. Okay, and some important integrals that you have to remember, which will be required for your numericals. Okay, thank you so much for watching this video. Thank you.